In this video, we'll talk through how to use some common financial functions that are built into Excel. Now that you know something about how to use functions and arguments for functions, we'll use some more advanced functions. You can see that Excel is open now to a worksheet here where I've listed some terms: loan amount, interest rate, number of payments, and payment amount. You'll also see I have a list of common financial functions that we're going to use over here. We'll talk about each of those as part of this video. So the idea behind financial functions is that I'm dealing not just with money here, but I'm dealing with the time value of money, which basically means that a dollar today is worth more to me than a dollar tomorrow, because if I had that dollar today, I could take that dollar and I could invest it somewhere and earn interest on it and have more money tomorrow. Now, it's the principle of time value of money that underlies all of the financial functions that we'll use in Excel. And frankly, it's what makes it difficult as a consumer to figure out what my monthly payment will be, for example, on a car loan if I just try to go in and figure it out on my own. So let's use Excel to work through some of these functions. Now, it turns out that when I take out a consumer loan, like a car loan, there are four things that tend to work together to help determine each other, really. So the loan amount, the interest rate, and the number of payments work together to tell me what the payment amount will be. Or in other words, the size of the loan, the amount of interest that I'm going to pay, and the number of months it's going to take to pay back that loan determines how much I have to pay each month. Essentially, any combination of three of the four can be used to calculate the four. And that's most of the functions that we're going to use over here will help us calculate one of these that's missing. So let's just assume for a second that I'm taking out a $25,000 car loan. And let's say my interest rate is going to be 5.9%. Now, the interest rate will be quoted to me based on my credit worthiness, so that's often something that's given to me. The number of payments, that's something I get to decide. That's how long I want to take to pay back the loan. Let's say I'm going to take 6 years to pay back the loan, or 72 months. Now, it's important to realize here that I'm dealing with months, and so number of payments will be the number of monthly payments I'm making, not the number of years that I'm going to take to pay back the loan. Now, this can get a little bit tricky because the interest rate that I've specified is an annual rate, not a monthly rate. So let's go ahead and adjust that. Let's make this a monthly rate by dividing by 12. So my 5.99% interest is really almost a 0.5% interest each month. Okay, so the payment amount then is calculated using the PMT, or the payment function. So when I type in payment as my function name, notice that I have 5 arguments, and some of the arguments have brackets around them. So let's talk about that. Rate is the interest rate for the loan, and that's going to be my monthly interest rate. NPER is the number of periods, or the number of payments for the loan. PV stands for present value. That's the present day loan amount. FV has brackets around it. It stands for future value, and that's a little bit beyond the scope of the class here, but it's another argument that I can throw at the payment function if I plan to have, say, a residual value other than 0 at the end of the loan. And type is the same thing. It's beyond the scope of the class, but it's another piece of information that I can give the function. Now, the reason that these two arguments have brackets around them is, as we've already mentioned, they're optional. They're not needed for doing the calculation, and an optional argument always shows up with brackets around it. So I'll just deal with the first 3 arguments. The interest rate is the monthly interest rate, or it's 5.9% divided by 12. The number of periods is the number of payments, so that's 72. And the present value, that's the loan amount. So now that I've referenced those 3 values here, I can hit enter. And notice that I calculate the payment amount to be $413.14. So one thing you probably noticed right away was the payment amount is a negative here, and the loan amount is positive. Now, why did the payment amount end up negative? That's an interesting question. Again, probably beyond the scope of the class, but let me give you a little intuition. The loan amount is really a positive to me. It's money that comes to me from the bank that I can use to pay for the car. The payment amount is a negative to me, or it's the money that I pay every month to pay off the loan. So you'll notice that there's really an opposite direction here for the flow of money. The loan comes to me, the payment goes from me to the bank. That opposite relationship means that I'll always have an opposite sign for the loan amount and the payment amount. That's just how it works. So let's go ahead and look at the present value function. The present value function is used to calculate the loan amount. So when I type in present value as my function name, notice I have 5 arguments again. Rate, that's the monthly rate. Number of periods, that's the number of payments. My payment amount, and then I also have future value and type again, and I'm going to ignore those this time around as well. So present value, interest rate, monthly rate, number of payments, and I'm going to reference my calculation on the payment amount here, and I should end up with $25,000 as my present value, which is really the loan amount that I'm interested in, or the amount of money that I'm earning today. Future value on our list over here. Future value tells me that if I were to save a certain amount of money every month for a certain number of months at a certain interest rate, how much would that money be worth to me at the end? So it's kind of the opposite way of looking at the present value, which is the loan amount I'm taking out today. The future value is how much I could save over time. So we'll use the future value function here to figure out if I were to save my payment amount every month for 72 months and earn 5.9% interest on it annually, how much could I save for those 6 years? So I'll enter FV as my function, have the same set of arguments, so I have the monthly interest rate, number of months I'm going to save the money, and my payment amount. We're going to ignore the PV and the type arguments again. When I hit enter, notice that if I were to save $413.14 a month for 6 years and earn 5.9% on that money every month, that I would save $35,588 at the end of the 6 years. I would have that much in my savings account. The rate function is used to calculate the interest rate, and like I mentioned at the beginning, if I know 3 of these 4, I can calculate the 4th. So if I know the loan amount, the number of payments, and the payment amount, I can calculate how much interest I'm paying on my loan. So let's go ahead and calculate it. I'll use the rate function. Number of periods is number of payments. Payment amount is the payment amount. Present value is the loan amount. Ignoring the other arguments that are all optional here, and hit enter. Notice it comes out with 0%. Of course, I need to show a little bit more precision in order to see that my monthly interest rate calculated here is the same as my monthly interest rate from above. And if I want to go ahead and make this an annual rate, I can take my monthly interest rate and multiply by 12 to see what the annual rate is on that loan. And as you can see, it's the same 5.9% that I started with. In the next video, we will talk about the effect financial function.